Good afternoon, everyone. It's Thursday, it's 2 o'clock, and welcome to episode 19 of the M Word. My name's Robin, or Rob, either works to be honest. Welcome to episode 19. Today we're going to be looking at Revit Families and talking you through. Sorry, I've got the giggles because I think my colleague's just dropped stuff all over her laptop. But hey ho. Yes, welcome to episode 19. That's put me off my stride a little bit. So Revit Families today, we're going to be talking you through how to create a family. Maybe you haven't created families before in Revit and you want to have a step-by-step on how to do that. Maybe you have and you want a little bit more information about how some of the parametrics or some of the intelligent works, or maybe even how to align those to relevant standards in the construction space. So for those of you that are new, welcome. We like to have a virtual tea break or coffee break on these Thursday afternoon sessions. But please give us a like, give us a subscribe, follow us on our social media channels, and check out our other videos and let us know what you want to see. We've got a lot of content out there now. Slightly below my like thing. We've got a lot of content out there now. Give us a like, give us a subscribe, hit the notification icon so you can see we go live. And we do these sessions as a virtual coffee break, warts and all, every Thursday at 2 o'clock. I'm from HQ today, so I'm broadcasting from the office in Tame. But as I say, just check us out on social media and you can see the upcoming schedule of stuff that we've got coming up. It's a hot one out of there today. It's the 11th of August, 30 odd degrees, 31 degrees outside at the moment. Took a walk to the shop at lunchtime and felt like a flump by the time I got back. It was so hot I was almost melting. But hopefully you're enjoying the weather where you are. Save that water. It's certainly a hot one, so hopefully you're having a refreshing drink while watching this. I know I've got a young viewer in my youngest, Ivy, watching this afternoon while her sister is at sports club. Hello! I hope you've not eaten all my ice creams, or my crunchy that I've got in the fridge, but see you a little bit later on. So without any further ado, let's just jump straight in and have a little look at Revit Families. So I'm just going to shrink myself down into the corner and share my screen. Much like always, this is warts and all, so I haven't really done any specific prep with regards to the model that we're going to be using today. I want to start everything from scratch and try and keep it as simple as possible to really talk you all through it step by step. Whilst I'm using Revit 2023, this process pretty much within reason will work on any version back to 2016, 2015, 2014, so on and so forth. That was lucky that I closed my Teams before some dodgy GIFs started coming through. We're going to use Revit 2023 and we're going to start a new family. So if you don't know, Revit's got two types of file format. It's got an RVT, which is your project, and we're going to be looking at an RFA, which is your Revit family file. So under families, we click new. And whenever we're creating a family, Revit has categories. So every component that you place onto a floor plan or an elevation or whatever it might be in Revit will have a category. It might be a door or a window. It might be hosted to a face, warmer mounted, ceiling based, so on and so forth. So it's really important that we choose the right category from our Revit family templates so that we are creating an object that Revit is going to recognize. They're all pretty straightforward, to be honest with you. It doesn't need to be overcomplicated. If you're creating a baluster, you use the metric baluster template. If you're creating a door, you use the metric door template. If it's a door for a curtain wall, you create the curtain wall door template. It's all pretty straightforward. There isn't anything overly complicated on there. And what we're going to do today is keep everything really generic. So we're going to use the metric generic model Revit Family template file, RFT, to create our Revit Family file, RFA. Now there are several of those. We're just going to use the generic one, just the standard metric generic model today. But you'll notice that you've got an adaptive one for placement on a ceiling, one for placement on a floor, 2 levels, pattern-based, so on and so forth. So you've got different ways to be able to control the placement of this family, but we're just going to keep it nice and simple. Select that one and hit open. This will launch the template. You cannot create new family templates. You're stuck with what you've got out of the box. So just make sure you select identify and pick the right one. And much like starting a project in Revit, you get the same interface, but a few different buttons. So we still have a ribbon bar. That ribbon bar is full of modeling tools like extrusions, revolves, sweeps, lofts, which Revit calls blends, and other little bits and pieces as well. We still have our real estate in the middle. We still have our project browser and our properties palette on the left-hand side. Pretty much you should feel right at home. But the main difference here is we're looking at an object. So we're looking at a component. And that component will have a reference level. So that's where it's going to be placed. We chose a generic family. So this is going to be a model that we place on the floor. So like a chair or a table or something like that. If this was wall-based or ceiling-based, then the reference level would be the level or the wall or ceiling that you're placing it onto. And then we've got a load of views around that to help us model. So I'm going to try and keep this as short and sweet as I can today. You know, these are only half-an-hour sessions just to give you a bit of a tip. So what we're going to do is we're going to use some datum points to set up a skeleton for our model to work with. Now we don't have to do this in Revit. It's just how I was taught all those years ago, and actually it makes a lot of sense to have a parametric skeleton that's driving the control of the model. And what we're going to do is we're going to create a box. So a really simple parametric box that gets bigger or smaller with some parameters, and then we'll just detail that out as we come through. So rather than just going straight in and drawing extrusion, I always start with these reference planes. Now a reference plane is like one of these here. So these are reference planes. They have names, and whilst they just look like a 2D element, they actually span 3D space. So these are like a knife slicing through butter all the way through our component. And what we're going to do is say create, and I'm going to create a reference plane, and I'm going to choose to place those reference planes around where I want my box geometry to be. So this is going to be the front of my component, so I'm going to place one just here. This is going to be the back of my component, so I'm going to place one just here. And then I'm going to have a left component and a right component. Again, I don't need to actually draw a box here, I'm just placing them roughly where I want them. I'm using some snaps just to get them aligned, just because I can, but I don't really need to do that, I just need to make sure that they are straight lines. If you want to name them, then great, you can, it makes it a lot easier, so I'm just going to call this one front. I'm just clicking on the actual line once and then clicking where it says click to rename to give that a front, a rear, a left hand side, and finally a right hand side. And then with those components there, I've now got some skeletal planes that I can work with. And again, before I start drawing any geometry, a little bit different to how I would usually model things in a CAD application, I'm going to place some dimensions onto these skeletal frames. So I'm going to use my dimension tool or press D on the keyboard, and I'm going to create some dimensions. Now, the first one of those is going to be a left to right dimension, like so, and then a back to front, or front to back, doesn't really matter, and I'm going to place those to the side of my model. If I just hit escape a couple of times, once to stop placement of dimension and once to cancel the dimension tool, just to come back to my normal selection, and I want these to be controllable. I know that if I move this plane here to the right, the dimension will stretch, and if I select this plane and lower that dimension, the plane will stretch or move. But I want there to be an element of control. I want to be able to control the size of this component through a property within my type palette over here. So what I'm going to do is I'm going to select that dimension, and I'm going to choose to link that dimension to a label. If you had parameters already existing for width, height, length, so on and so forth, you could just select them from this drop down list, but again, this is completely from scratch, warts and all. So I'm going to create a new parameter to link to that label. We can choose a family or shared parameter. Check out our content on YouTube and other channels, because we've got some great videos that explain what they are and how they work. But I'm going to create a family parameter. I don't need this to be scheduled or anything like that for the purpose of this. So we go with a family parameter. I'm going to call that width in the name, if I can spell it correctly. There we go. And I want that to be a type parameter. Okay. The difference between type and instance parameter is that a type is always going to be the same value for every single type that you have in your model. So if you've modeled a desk and you have one type of desk, which is 1.5 meters by 750, that parameter will be the same for every placement of that desk. An instance parameter is specific for each one of those placements. So you might use it for a mark or an identification number or a usage or something like that. We're going to select type. It knows it's a length parameter because it's related to a dimension. And I'm going to group it under dimensions. And if I wanted to, I could give it a tooltip within these triangle brackets that said the length or the width, sorry, of the box. Press OK. Press OK. And then we have our width. What that means in essence is I can still move this around. But if I look in my family types and look at my width here, it's directly linked to this dimension. So if I make this 5200 and hit apply, we can see that the dimension updates, which is exactly what we want to do. Let's mimic the same thing here for the depth. Create a new label. By the way, there's the functionality I spoke about earlier, where if a parameter exists, we can use it. Let's again create a new one. It's going to be a family parameter because we don't need to schedule it. If you need to schedule these and put them onto schedules, you need to use a shared parameter. Again, check out our YouTube for more videos on those. Let's come in and choose depth. Again, it's a type parameter. I'm not going to bother with a tooltip this time, and that's going to place that there. Before I go any further, I've got width and depth. I might as well go and look at controlling the height of this as well. So let's change my view. I'm just going to close these ones just to show you how to reopen them. So let's change my view from the reference level, the floor that I'm placing this component on, to an elevation. And let's go ahead and look at the front elevation. And we can see here, that's the ref level that I've just been creating those work planes on. But you've seen here that they span in 3D. So there is my right-hand side, and there is my left-hand side. I want to create a final plane up here, and I'm going to call that top. With that, I'm going to say, this time, the other route of creating parameter. Let's go into my family types. Let's create a new parameter from scratch. Sorry, not a new type, a new parameter from scratch. Family parameter, let's call this height. Again, type, common, it's a length, and I group it under dimensions. I'm going to set the height to 2 meters, and this time select the dimension from the reference level. Make sure you're picking up the right plane there. If you look at the bottom left-hand side, when you hover over something and hit tab, it will show you if you're selecting the right thing. So I'm now selecting my reference plane to the top, and I'm going to place that and select the label height. So you can select those in any order you want. You can create the dimension on the fly, the parameter on the fly, or you can do it as we go through the process. Let's carry on. Let's go and I've completely lost my trail of thought. Sets me right for looking at my watch. So we've got a height in there, we've got this top plane, fantastic. So what we're going to do now is actually start creating some intelligence around how these work. So jump back to your reference level, grab your dimension tool, and we have a width, but I want this always to be symmetrical. I want it to be even either side. So no matter how long this thing is or how short this thing is, I want it to be symmetrical around the center. So what we're going to do is grab a dimension between the left, the middle, and the right in a single click sequence. That will create me a chained dimension. I'm just going to drag this just underneath my width here, and then I'm going to click the EQ sign. I want this dimension to have equality across both sides. In other words, I want the left-hand side and the right-hand side to be equal from the center. What that does is it allows me to now make this parameter bigger, and it will start stretching in both directions symmetrically around the center. I'm going to do the same thing front to back. So again, in one click sequence, click once, move, click again, move, click a third time, and then click to place the dimension before setting it as equal. We now have these components or these work planes that are now working parametrically. And I can confirm that by, as I say, clicking them and dragging them to make them bigger and smaller. I can see that both work planes are moving and the depth is updating. But I can also come in and change through my family types the depth to 3000, so 3 meters, and I know that it's going to be 1500 to the center, 1500 to the front. Okay, again, you can confirm that with a measure tool or whatever else that you want to use, should you want to. But I'm basically drawing a skeleton and getting that skeleton to be correct and update with regards to the dimensions around it. Now that I've got that, I can basically skin that skeleton, if you like. Bit of a gross thought, but I can now place my geometry over the top of that skeleton and just make some simple alignment locks to say that I want the geometry to follow the skeleton. So all I'm going to do is go to Create, go to Extrusion, and most functions in Revit from a modeling perspective in Families work exactly the same as any other 3D tool out there, whether it's SketchUp, whether it's Inventor, whether it's Pro Engineer, SolidWorks. We start with something 2D and then we have a feature to make it 3D. So I'm going to create a 2D rectangle and then I'll extrude it, so I'm going to pull it up to create a 3D cube. But because I've already got all the intelligence in this skeleton and I know it works with the skeleton, I'm just going to randomly place my lines, and then I'm going to use AL, align, or this button here, to align. First click the master, and then click what you want to move, and then lock. What you want to move to, and what you want to move, and then lock. Go all the way around. Now I know that I could just trace over these lines and press lock straight away. I'm old school, this is how I do it, I'm sorry. But hey ho, it works for me, and I don't typically have any problems. So now these lines are linked to the skeleton. Before I accept the extrusion, I'm going to go into my family types and confirm that by changing the depth to 2500 and changing the height to 750. Not the height, sorry, that won't make any difference here or there. Change the width to 3000. Hit apply, everything updates. Parametrically it's working, which is fantastic. It's doing what I want it to do. If I now press the tick, go and have a look at this from the front, there's the top of my extrusion. I'm now looking at it from the side, from an elevation. So here is the reference level and here is the top. Why is it so small? Well, because it's only 250 mil high, because that's my default for this extrusion. I could change this dimension to anything, or I can just say, again, align, oops, AL, no, not AK, that's something else, AL, there we go. The top reference plane to the top of my box and lock. Let's confirm that that is doing the same thing. Family types, height is going to be 2250 and apply. Great, everything's updating. Let's go into a default 3D view by pressing this house up here, or 3D view from the menu. Change this into a fine level of detail and look at a shaded view, and here is our box. And we should now be able to say family types. Let's go to a depth of 1000. Let's go to a height of 3000. Oops, 3000, and a width of, I don't know, 1250. Hit apply. The box will update. If I then make this 3000 cubed, the box will update. Why did I do it this way? Why did I first make a skeleton, constrain and place rules, for more of a better word, onto that skeleton, and then just align the geometry? Well, it all boils down to keeping things simple. So what we're doing with work planes is we've got no geometry there. We don't have any sophisticated sweeps. We don't have any blends or lofts with very aesthetic or smooth surfaces or 3D. We've just got work planes. If it works with work planes, you go to the next step of sketching your geometry. If it works with the sketch and it works with the work planes, it's going to work with your 3D. So it's just really stripping it back, doing it once, doing it simply, getting the parametrics to work in a way that you haven't got anything complicated to look at, and just building it up by part by part. And doing it this way makes things really, really straightforward, which is great. Yes, it's only a box, but the same process works for whatever it is that you're drawing. And actually, if you look at pretty much any of the Revit default families or the ones that you might download from the National BIM Library or anywhere like that, you will notice that they will all be created and modeled using the same kind of structure. Work planes with parametrics and dimensional constraints, and then geometry assigned to those components. So let's just take this one step forward from a geometry perspective and maybe show you how you remove some detail and how you maybe add some model line detail. And then from there, we're just going to have a brief discussion about some of other functionality as well, just to finish off. So if I wanted to take away detail, I follow the same process. So let's say that on the front of this unit, I want to have an indent. Now, from a modeling perspective, you need to ask yourself why you're modeling that kind of detail. Why are you cutting material out of here and creating lots more faces, shadowing and shading and stuff like that? Do you need that detail? Is it important from a collaboration exercise or a coordination exercise? Or is it just to make it look nice? Again, remember what's required to place, constrain and use this in a construction model. Sometimes actually what's more beneficial is bounding boxes and shapes and envelope shapes rather than all single dancing families that have all sorts of intelligent parametrics. Try and keep it simple. It will help the wider project and keep the model as small as it can be. Speed up your workflows. But if you need it there, then you might want to add it. So to continually add detail onto this, it's really straightforward. We just continue to follow that process. So if I go and look at this from the front, using the front elevation, I can then come in and basically start on here. Now, I'm going to follow the exact same process. So I'm going to come into create, I'm going to create reference planes, and I'm going to create a plane there, 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 and there. Again, I'm not too fussed about exactly where they are initially, but these are going to be offset in. Okay, they're going to be inside my component offset. So I'm just going to roughly make those look kind of about right. And then we're going to add some intelligence. So I'm going to use my dimension again and go from there to the plane. Remember, always use those planes. If you can't grab it, hover over what's in front of it and press tab to cycle through. I'm going to place one of these dimensions all the way around the outside. I'm basically creating an offset. I'm doing it very manually, but I'm creating an offset for me to use for these work planes all the way around. I'm going to go and create my parameter. I'm going to call it internal offset. I'm going to press OK. And I'm going to select each one of those in turn and change their label to internal offset. So they're all using one parameter to control their size. Maybe I want that internal offset to be a little bit smaller. So let's go with 100 millimeters for the purpose of this. We're then going to create a void form. I want to cut material away. Extrusion and blend and revolve are only for adding material. Whenever you want to remove material, you use a void. So I'm going to use a void extrusion. Same process, I'm going to create a square, or a rectangle, sorry, in the middle, and then I'm going to use align, either button or AL on the keyboard, and align them to my new offset work planes. I haven't named those offset work planes. I should really practice what I preach and follow my best practice. What can I say? But there we go. We align them. They're locked. I could then come in and just test again. Test to make sure it works. So let's up that to 250. Make sure that the pink lines and the work planes move, which they do. Great. Press the tick. Go to my 3D view, and I have my my void, which is being created. Now, the void isn't cutting anything yet. I shouldn't have deselected it, which is really frustrating. The void isn't cutting anything yet for two reasons. Number one, I've modeled it in the middle. I've missed a really important step. Now, the question you have to ask yourself is, did I do that accidentally or did I do that on purpose? If you did do it accidentally, like I just did, it's really easy to change. Okay, if you did it on purpose, then great, happy days. But what I should have done when I was creating that void is I should have set my work plane. So any flat face can be a work plane as well as what you've drawn inside of here. So what I should have done is selected that, that functionality before I went ahead. So with the void form, can I select the void form? Give me the void. Please give me the void. Here we go. Select the void. And with the void selected, we're going to say edit work plane. This will allow me to choose a plane. So I can choose a plane based on picking one, or I can choose a plane based on giving it a name. Okay. So I've got two things basically that I can do there. I can either say pick the front face of the box, or remember there was a work plane there that that I wanted to use. So if I pick my void, and hopefully Revit is going to be nice to me, we can. They joined themselves. They have, haven't they? Hang on. Yes, they have. Typical Revit. If we select that void and say unjoin to get the void back, you and you, come on. No, okay, I'll tell you what I'll do. As it was an accident, I'm going to go back and do it again. I don't often make mistakes, but sometimes. Here we go. So before you start creating that void extrusion, set the work plane. So create, set your work plane, either pick one that you've made, I'm going to use the front one, and then start modeling. And you can set it afterwards, but for some reason I was having trouble selecting the void. So once you've done that, then go ahead and create your void extrusion. Make sure you are working on the right plane, and go ahead and create your geometry. My apologies, I will blame the heat. It's just me, to be honest, it's not the heat at all. And we'll just align those like so. Again, we have an extrusion start and extrusion end. I want this depth to be the same as maybe my offset times 3. So we could say equals offset times by 3. I didn't call it offset, did I? I called it internal offset times by 3. Okay. Ignore me. We'll do that in a second. So there we go. If I come around now and select why are you in the middle? I'll tell you what, I'm just going to give up. I'm just going to do it manually. I don't know what I've done wrong there. Someone will see this, scream at me and say, what'd you do that for? I'm pretty sure I set the work plane as the front there. Hey ho, never mind. Constraints are not satisfied. Constraints. Sinking ship. I'll try this one more time. Why are you in the middle? I've told you not to go in the middle. Set work plane front. Third time's a charm. You just have to say it in that sort of sarcastic way when you say it. Then make a tick. Then you have a void. Fantastic. Once you've got that void, if you just deselect, it will cut. If you want to change what it's cutting, you just use the cut, uncut, or join, unjoin commands to get it to work. But there we have this cutting detail through. Goodness me, that took a lot longer than it needed to. If there's detail that you want to show that you don't want to have geometry for, because as I said earlier, you're happier with an envelope shape, then we can use model lines for that, and the process is exactly the same. So from the top, let's imagine that we want some detail on the top. You would come in and create some model lines. With those model lines, once again, you need to make sure that you set the work plane first. So let's go to the reference level, or more appropriately, let's go to the reference level. Perfect. We'll say create, we'll say set the work plane, and we'll say on the top, hit OK. And I'm just going to use these two here to control this bit of detail. And we're going to say that we've got model line. I'm going to create a rectangle, draw it here. And what that will do is it will create you these model lines on the geometry there. With those, we can then create some alignments and some constraints to then constrain it onto those work planes. lock it in position, constrain it onto this work plane, lock it in position, so on and so forth. But that model line is always going to show in that 3D space if you wanted to, which is great. So you can show, that there might be a louver there or a cut there or anything like that without actually modeling it, which is fantastic. All of this detail can be controlled with these levels of detail, which is the last thing I'm going to show you on the modeling front, which is really easy to do because under the create here, when you select things, you can control when they show under this visibility setting. So if I select this void here, I can go to my visibility settings, there we go, and I can choose when that is or when that isn't shown. So for the purpose of this, I can say I want it to display just in 3D views. Don't bother showing the cut when it's in 2D. And also don't bother showing it if we're in coarse or medium. With regards to the model lines, I can do exactly the same thing. I can select those model lines, change the visibility settings and say that I only want them to be shown in plan and only in medium and fine coarse levels. If I save this onto my desktop, just call it Family 1 for the purpose of this, and create a brand new project to stick this in, you'll see those come to life. So if I say place component, browse to my desktop under load family, select the RFA file, I'm just going to place one of these down here. So we're going to 3D view. I can see that at the moment I'm on a fine level of detail. If I drop this to coarse, you can see that the model line there has all but disappeared. Should have actually disappeared, but it's all but disappeared. We can go through and do the same thing in a plan. So if I go across onto my floor plan, just here, I can change from fine to coarse level of detail, and it will update as necessary to show you or not show you geometry as you have selected or as you see fit. It's really fairly straightforward from that perspective. So modeling is a bit finicky, but it works. When it comes to properties and metadata, certainly from a building information modeling perspective, again, it doesn't have to be difficult. Under our family types area, you've already seen how we've created parameters against certain dimensional constraints. So if I need to put some parameters in there from a BIM perspective to be compliant with Uniclass, to be compliant with Kobe or whatever else it might be, I just have to create parameters using the right naming conventions, and then I need to use those to place a value against them. For example, I'm going to go in and create a new parameter. And let's not worry too much about naming conventions for now. Again, I'll let you go ahead and look at our YouTube channel for some of the videos that my colleagues have put up around some of the 19650 standards, 8541 standards, which are more viable when it comes to families, although they're soon to be replaced, and some of the Kobe stuff as well. Let's just say that we've got a Uniclass code, which is going to be common, piece of text, and I'm going to group this maybe under the IFC parameters. And then I'm going to have a Uniclass class, there we go, description, and I'm going to do the same thing, oops, wrong button, Uniclass description, again it's a piece of text and it's under IFC parameters, and let's just go and grab from the web those details. So let's come in here and say Uniclass tables. Let's go onto the MBS here, and then let's search. Where are my tables gone? This wasn't what I was expecting. Uniclass tables. Try that one. There we go. Let's do a search for box and see what comes up. It's a collection box, that'll do. So we'll go to collection box. We can see that they've got all of these different categories, PR codes. So I'm just going to use this one. So I'm going to place that into my Uniclass code, and then my Uniclass description is going to be collection boxes. There we go. Apply. Okay. So whether you're adding geometry or whether you're adding parameters, the process is really straightforward. You add the parameters, you give it the right naming convention, and you give it a relevant or NA value if that value is not appropriate at that stage. For example, a serial number or an asset tag from a Kobe perspective wouldn't be relevant until the thing's actually installed. So you need a placeholder for the property with an NA value, for instance. Yeah, okay. So that, I think, was pretty much all I was going to cover, with a little bit of issues around this void here. Serves me right for using voids, but hey ho. So we've created our first family. It doesn't need to be difficult. It's fairly straightforward. And if I just show you the same process for creating a wall or a door or something, new family, I'm not going to go through the whole thing, but if I just say metric door, which is clearly a more complicated component to draw, you can see that you get a base wall and then you get a load of work planes. It's the same process. Add work planes as you need to for any detail in the paneling, any detail around the framing and the door, and model around that wall that it gives you. Once you've modeled around that wall that it gives you, it would load a door and that door into your family, or into your project, sorry. So again, it's fairly straightforward. It's been a whistle-stop tour for half an hour or so. I hope it's been useful. Remember to check out our other socials for other videos. We'll be back next week at 2 o'clock. Let us know if you have any questions or comments, and we'll back to you next week. Thanks for watching. Take care. Enjoy the sunshine.